Hello students, this is Mrs. Bowles, and today I'm going to talk a little bit about latent heat calculations. Again, we're working in Q. We're working with problems where there's an energy change or a heat change, and in this video I'm going to be talking about the ones with the X's here, situations where you're involving a phase change. Not heating and cooling, but a phase change. So a phase change in where you're melting, or freezing, or vaporizing, or condensing. Those are the kind of problems we're going to be working on today. So again, phase changes are a solid changing to a liquid. In that case, we call that the heat of fusion. We would use something called the latent heat of fusion to calculate that. So the formula for that would be Q equal to M. M is again the mass, times another constant called the H of fusion. H of fusion, or enthalpy of fusion. It's the amount of energy associated with that change from a solid to a liquid taking place. So that one is used upon melting and freezing. In the case of a liquid changing to a gas, we would use Q equals mH, and this time is H of vaporization. These are used for evaporating, boiling, or condensing. And again, the H vape is a constant. Enthalpy of vaporization. Every known substance has its own value for that, and those are the ones that you use when you're doing the calculations. So let's give a look here. If you were working on a couple of problems such as these, and you read the problem, and the problem mentioned melting or freezing, you would know you were going to use Q equals mH of fusion. If the problem talks about a change in temperature, again, you go back to the Q equals MCAT formula. If vaporizing or condensing are mentioned, you would use Q equals mH of vaporization. And this part of the work here shows you that there are different constants associated. You always need to make sure you have the right constant. This last column is the constant C, which is specific heat. This one is fusion, and this one is vaporization. So you would have to look up the constant for the type of substance you're working with. So let's try a couple of problems here. Excuse me. So look at the first one here. The first one says, how many joules must be added to 10 grams of water to raise its temperature from 10 to 15? What formula do you think you would need for that one? If you said Q equals MCAT, you're right. Notice there's a temperature change given. So you would subtract those and get 5 and plug into Q equals MCAT with 10 grams and find the specific heat of water, which is 4.18 joules per gram degree. The second one here has 20 grams of gold going from 10 to 50. Again, on this particular problem, you would need to go back and get the constant for gold. I believe it's over here. Let's see, gold. Yep, 0.129. And you would plug that into Q equals MCAT for that problem. How did I know that? Because again, it's got two temperatures. Whenever there are two temperatures, that means it's either heating or cooling taking place. Take a look at this one. This one's got two variables and two situations that you have to consider. So in this one, you would need to take two different problems and set them equal to each other to solve this one. So there's quite a number of differences in different types. You would need the constants in order to handle each of these. So doing this first one, number 5, you would use Q equals MCAT. It would be 10. And then the specific heat for water, if you take a look here, is the liquid water, so it's 4.18, and then times 5 to find Q. None of these specifically use latent heat. I'm guessing I have some problems here later on that use latent heat. Oh boy, oh boy, oh boy. So whenever you run into a problem like number 1 here, you would definitely use latent heat. Look, it says melting. Right away, that's a giveaway. So you would just take 245 times the heat to melt. So it's heat of fusion of aluminum. So look up aluminum, heat of fusion 398, and you would multiply that by 245. That's how you do those. Some are more difficult than others, but there's a little introduction for you.